This study was from the Southampton Women's Study, published in 2014. And this was a phenomenal study that measured diet before pregnancy and during pregnancy, and has data on body fat levels in children at 4 years of age and 6 years of age. And this study didn't look at sugars in particular, but looked at glycemic load and glycemic load in early pregnancy. And specifically, this finding was unique to glycemic load of maternal diet in early pregnancy, not in late pregnancy. The way they've shown the data here is statistically complicated, but basically the height of these bars is related to level of adiposity in the offspring, in this case at 4 years of age. And you can see the association was significant with the trend, with the highest quarter of maternal glycemic load in early pregnancy being associated with a higher infant or childhood body fat at 4 years of age. And they showed the same effect at 6 years of age as well. Similar finding was published just last year from Project Viva, very similar pregnancy cohort done here in Boston. Very similar study, but they looked here particularly at sugar-sweetened beverage consumption during pregnancy in just over 1,000 mother-child pairs. And what they showed, again expanding this finding, was that for each serving of sugar-sweetened beverages in pregnancy was associated with multiple different indices of obesity in the offspring. I think this was at 7 years of age. People in the audience might correct me if I'm wrong on that, but I think it was about 7 years of age. Now, interestingly, around the same time, in fact, a year before, from the Canadian birth cohort study, very similar finding, but this time we're looking at non-nutritive sweetener consumption consumed by mothers during pregnancy, how it affects infant body mass index at 1 year of age. This study is in its much earlier years of infancy, so they don't yet have later data available, so they just have the 1 year infant data. Nevertheless, they had a pretty significant finding. They have 3,000 or just over mother-child dyads in this study. Healthy women, for the most part. 30% of women consumed artificially sweetened beverages in pregnancy. 5% consumed daily, and daily consumption was associated with infant BMI at age 1 year of age. And here's the data. Interestingly, they did not find any effect of maternal sugar-sweetened beverage consumption during pregnancy on infant BMI at 1 year of age. We'll see whether this kicks in later in life, but at 1 year of age, the effect was much more pronounced, interestingly, for maternal consumption of artificially sweetened beverages. And you can see here a twofold higher odds ratio in those who were consuming it daily. Also a highly effect, not quite as high, amongst intermediate consumers, 2 to 6 times per week. So there's a twofold increase in risk of infant overweight by 1 year of age as a result of maternal consumption of non-nutritive sweeteners during pregnancy. This was not an isolated finding, because around the same time this study came out from Denmark in 2017. This study was done exclusively in women who had gestational diabetes, which is interesting because a lot of women who have gestational diabetes may be advised to drink non-nutritive sweeteners in an effort to reduce the glycemic load of the diet. So in this particular study, in fact, 50% of women were consuming artificially sweetened beverages in pregnancy, and 9 consumed daily, so slightly higher than the previous study, possibly because of the GDM nature of this population. But exactly the same finding, actually. If you looked again across the range of consumers, frequency of consumption during pregnancy, again, there's an increase across the spectrum. Exactly the same risk ratio, actually, of about twofold higher increase of risk, and this was at 7 years of age. So this was slightly later in life. So the effect is sustained by daily consumption, and there's an intermediate effect at lower levels. So what are the potential mechanisms? These are just the epidemiological associations. In our work now, we're just beginning to dig into this to try and understand what could be the mechanisms. So one of several possible mechanisms, some of these products, either themselves or their breakdown products, can cross the placenta and affect development, can affect the developing fetus. So aspartame, for example, is broken down into methanol and formic acid, which many studies have shown are perfectly safe perhaps in healthy adults, but we have no idea how those compounds may affect the developing fetus or the developing infant. We know from adult studies, again, these compounds can affect microbiome. We have no idea how consumption during pregnancy affects the maternal microbiome or the infant microbiome development, which we know is rapidly evolving in the first few years of life. We know from animal studies, several, I wouldn't say extensive, but a few animal studies have shown that when you expose pregnant mothers to non-nutritive sweeteners, you can affect taste receptor development of the offspring and promote even greater preference for sweet taste in the offspring. Non-nutritive sweeteners also can promote adipogenesis. As I mentioned, in vitro studies have shown that, in culture studies, and studies have shown non-nutritive sweeteners can be detectable in breast milk and again may be inadvertently transmitted to the infant. Switching gears a little bit, I'll talk about some of the work we've done in collaboration with my colleague Scott Konofsky, who's in the biology department at USC, who studies animal models in rats. And he's developed these very useful techniques to measure hippocampal dependent memory and hippocampal-based cognitive outcomes. I equate this with how easily I can find my car in the parking lot after I've flown in from a 12-hour flight. So they stress the animals quite heavily with noise and light, and they measure how long it takes for them to find an escape route. Sound familiar? So they measure this in rats, and it's fairly reproducible. And just as a little pretext to that, there is evidence from human studies, from epidemiological studies, that sugars may in fact affect these cognitive outcomes. This is a large study from Australia in over 4,000 children that looked at the negative impact of sugary beverage consumption on academic performance. So we know, again, there's an association between consumption in childhood of sugary beverages, whether it's less than 1 glass per day, 1 glass per day, 2 to 3, or 4 to 6, you can see greater consumption is associated with worse score in grammar tests, reading tests, writing tests, and numeracy tests. So this was published last year. And also from Project Viva, just published earlier this year, really interesting study. Again, this was a birth cohort study looking at the effect of maternal consumption on child cognitive outcomes. We can see that they looked at the effects of maternal sucrose, maternal sugar-sweetened beverages. These effects are per serving, or the effects of maternal diet soda per serving. And you can see here, for learning ability at age 3, there was a significant effect only from maternal diet soda. For verbal learning measured at age 8, there was a significant effect of maternal consumption during pregnancy, small effect of sugars, slightly bigger effect of maternal SSB, and a bigger effect of maternal non-nutritive sweeteners. Same for non-learning verbal, and for visual memory, just a small effect at age 8. But back to the rats for a moment. So he's designed these tests, and in this particular study, we were particularly interested in whether exposure to free ad lib access in the rats to water, sucrose, or high fructose corn syrup based solutions, how it affected this test, spatial memory score, how easily you can find your car in the parking lot or escape from a crowd. And you can see that they're in adolescent rats, so apparently rats do have adolescence as well, but there's a significant effect of sucrose and in particular of high fructose corn syrup on this test, but no effect on adult rats. So this shows that sugars again can affect development. So during this adolescent period in rats, the brain is still actively developing, and this is when there's a significant effect. And in these particular studies, we were able to dissect the brain, take out the hippocampus, stain it for inflammatory markers, and in fact, in the same paper showed that this is associated with inflammatory markers, specifically in the hippocampus, as a result of exposure to these sugars. No effect in adult rats. Remarkably, in a follow-up paper published just last year, they did the same experiment during day 26 and day 56 is when equates to adolescence in a rat. That was when they had the free ad-lib access. After adolescence was done, they removed the sugar-sweetened beverages and let them grow up to be adults. 4 months later, did the same test, and lo and behold, the same effect was noted. So in other words, this disruption of this spatial memory test was programmed, it was irreversible as a result specifically of exposure during adolescence. Now, he hasn't yet done the experiments of exposure during pregnancy or during pre-weaning or other developmental periods. At this point, he has only done the exposure during adolescence. Now, in the same study, we also looked at the effect of these sugars on gut microbiome. We published this last year, and we found pretty major effects in the gut bacteria as a result of sugar exposure in the rats. We didn't see any difference in this particular study based on the amount of fructose to glucose, but we did see an overall effect of sugars. So the dots in red show bacteria that were significantly altered as a result of exposure to sugars. And these are the top hits. These are the top bacteria. Most of them are increased on sugar as compared to water. This one, Prevotella, is decreased. But you can see there's a remarkable shift in the gut microbiome profile after exposures to sugar. We have some data. This is not yet published. This is stuff we're working on. This paper is about to go out for review, but I'll share it with you today. In this particular study, these are not adolescent rats. These are adolescent children. You can see there's about 100, can't remember the number. It looks like about 100 children, lean and obese. We measured diet very carefully with triplicate 24-hour recalls. And we looked across the spectrum of the diet at different macronutrients, from fats to carbohydrates, fibers, and proteins, at whether or not we could find any associations with the gut microbiome. And these are the only two significant associations that survived multiple adjusting, and both of them were related to fructose. So we had no other significant dietary associations in this particular study that were related to any factor of the gut microbiome except these two findings. Both of them, you can see that high consumption of fructose reduces the bacterial load. In this case, these are two friendly bacteria, Eubacterium and a strain of Streptococcus. And you can see the associations aren't exactly striking, but nevertheless they are significant even after multiple adjustment. And here we have evidence that high levels of consumers of fructose may eliminate friendly bacteria from the gut. And of course, this is something we're very interested in working on, and we're continuing to work in this area. The last segment of the talk, I'm going to talk about breastfeeding as a critical period for infant development and whether there are transmission of sugars in breast milk and whether or not this can harm the infant, and whether there are other sugars in breast milk that may be protective. So human breast milk is a very diverse mixture of bioactive nutrients, including sugars, mainly lactose. But there are also these other sugars called human milk oligosaccharides. These are